March 2018, paper 6. The student used paper chromatography to separate a mixture of colored dyes. The diagram shows the apparatus used. Draw a line on the diagram to show the level of the solvent. Of course, the level of the solvent should be below the baseline. Suggest a suitable solvent to be used, water. Always use water unless the examiner said that the substance being analyzed is water insoluble. B. What could be used to put the mixture of colored dyes onto the paper, a dropper or a teat pipette? The clips hold the paper in position. Why is it important for the chromatography experiment? We need to hold the paper in position so the baseline doesn't go below the solvent level, and in this case, the sample will dissolve in the beaker. So the mixture is above the solvent, or so the sample doesn't dissolve in the beaker, or in the solvent in the beaker. Okay. Give one conclusion that can be drawn about dye B. It contains two substances, or it contains substance D. Suggest why C remained on the baseline. If anything remains on the baseline, this means it's insoluble. That's why it didn't move at all with the solvent. In F, he asks you to calculate the RF value for A. The RF value is the distance from the baseline to the center of the sample, or the spot, divided by the distance from the baseline to the solvent front. The range accepted in the mark scheme is 2.8 to 3.2 as distance x, and 5 is distance y, so x over y will give you an RF value between 0.56 and 0.64. Anything between these values is accepted. Question 2, he's investigating the reaction between hydrochloric acid and an aqueous solution of sodium carbonate labeled L. He used a measuring cylinder, which is inaccurate. He used an indicator called thymolphthalene, which may cause a difference in the endpoint calculation between this indicator and other indicators. Okay, he filled the burette with HCl, and he started titrating. The readings are 11.6, and the difference, of course, is 11.6. In the other experiment, he used a different indicator, methyl orange. The reading is 23.6 and the difference 11.6. Then he rinsed the conical flask with distilled water and repeated using a different indicator, using the same indicator, which is methyl orange, and then he's adding the hydrochloric acid from the burette, 24.1, 0.9, and 23.2. Okay. The difference between experiment 2 and 3 is that he added methyl orange into conical flask from experiment 1, but he didn't rinse. Here, he emptied the conical flask and rinsed. What color change is observed in the conical flask? Of course, from yellow to orange, because it was added to an alkali or a base, which is sodium carbonate, and it changed into orange color because neutralization took place. Why was the conical flask emptied and rinsed with distilled water at the start of experiment 3? To remove any impurities or residue or solution remaining from experiment 2. Before starting a new experiment, you must clear the conical flask from the remains of the last experiment. Complete the sentence. Experiment 3 needed the largest volume of dilute hydrochloric acid. Obviously, you get this from the difference. This is the largest difference, 23.2 centimeter cubed. Give the name of a more accurate piece of apparatus for measuring volume of solution L, burette or pipette. H, what would be the effect of the results if solution L were warmed before adding the hydrochloric acid? Take care, this is a very tricky question. No effect, because we're not measuring rate. Rate is only affected by temperature. There is no change in the concentration of the conical flask alkali or anything. So we will not have any change or any effect on the results when we warm the mixture. We're not measuring time. I determine the simplest ratio between the volumes of hydrochloric acids used in experiments 1 and 3. In experiment 1, we used 11.6. In experiment 3, we used 23.2. In order to get the ratio, divide the larger number with the smaller one, you will get 2. So the ratio is 1 to 2. 2 to 1 is not acceptable. 1 to 2, because he said 1 and 3. Double I suggest why the volumes of dilute hydrochloric acids used in experiment 1 and 3 were different. This is a very nice question. Why did we need different volumes in experiment 1 and in experiment 3? He didn't change the concentration of sodium carbonate. Take care. The only thing that changed between the different experiments was the indicator. In the first, he used thymolphthalein, in the second, he used methyl orange, okay? So this could only be the reason. This is the only thing that changed in both experiments. Different indicators were used. That's why different volumes of acids were needed. Maybe different indicators have different sensitivity to the acid. J suggests why universal indicator cannot be used in these experiments. Universal indicator is never used in titration because it gives the more than one color change. It will not help us find the endpoint. Suggest how reliability of the results could be checked, repeat, and compare. Repeat the experiments, compare the results, or you can say take average. Two substances, the cations and anions question. Question 3, two substances M and N were analyzed. M was iron 3 chloride, so we know the cation and the anion, and we know nothing about N. Appearance of M is the color of the iron 3 precipitates, which is reddish brown or just brown. Then he added silver nitrate, which is a test for halides. We have chloride, so the result is white PPT. Dilute nitric acid and barium nitrate were added. Barium is test for sulfate. We don't have sulfate, so no change. DI, he added drops of aqueous sodium hydroxide again to M, brown precipitate due to the presence of iron 3. Excess sodium hydroxide, no change because it's insoluble in excess. You can say insoluble in excess, of course, or no change. Tests on solid N, the solid looked green, so we think transition metal, okay? We can think iron 2, or we can think copper. Copper is, copper carbonate is very greenish. Test 1, he heated the solid turned black. This confirms copper, because copper carbonate, when it's heated, it thermally decomposes to give copper oxide and carbon dioxide. This is green and this is black, okay? Lime water turns milky, this is the test for CO2. The flame test gave us a blue-green color. This is the test for copper, okay? This is the flame for copper. Identify, name the gas produced, of course, carbon dioxide, as it turned lime water milky. Identify the solid, you can say copper carbonate, or you can say transition metal instead of copper, if you didn't know that it is copper 2 positive ions. Of course, the copper, we knew it from the flame test. If you didn't remember the flame test, don't leave the answer, just say transition metal. This was March 2018 by Mr. Marco Medhat.